Hi everyone, Abdi is talking for asART 3D and motion graphics. And today I would like to show you how I use tyFLOW in order to create some cloud simulations. So in this example, I'm going to start with a table and then we have other scenes that I'm going through with you guys. Let me start creating my shape for my tabletop cover here, and I'm going to do that with a star. So set the first radius to 100, the second one maybe to 80, and then go and round these corners here. There's 16 to 8. So and then bring up my shape, go to the modifier list, add a garment maker to that, and the garment maker density we can set that to 0.5. So we have a high dense mesh, which helps a lot for simulations of a cloth and fabrics and stuff like that. And with all that set up, we can go and create a tyFLOW. So we center it just for no good reason. And then open the editor. I'm gonna start setting up everything with the default values and stuff. And in this tutorial, I'm not gonna use CUDA because I don't know how many people are using tyFLOW Pro and how many of you guys are using the free version. But the aim is that everyone can actually follow along no matter which version you're using. So this is why I decided to go without using CUDA and do everything what we need just without it. So let's go and start bird object here and pick our shape, and then press tab, type in cloth bind, and press tab again and type in force. In force we go and set our gravity to minus 0.3, and we also need a collision operator so we can define the table as our collision object. So for now I'm going to leave everything the way it is. I'm going to enable the ground collider and just run the simulation to see what happens and what we have to fix and how we can do that. So let me turn off my wireframe and let it go. So this is what happens right now. Pretty useless actually. So the first reason for that is time step. We have to bring that thing up to something like 1/8 or even higher. I'm going with 1/16 in such a case, and that will just retain the shape much better of what we have here. So let's go and just animate again or simulate it again, and there we go. So that's it's not stretching that much, and it retains the mesh form much better. So that's the first thing. And now we see that the table is just coming through the stuff, and that is something we can go and fix with our radius here. Set it just to 1 and simulate again. Now as you can see, the problem is solved with the collision. So the next thing is that while movement, if I go and simulate that further, it will just go and move for a while until it settles. That can take really a long time sometimes. So in order to fix this, I'm going to use a slow operator. So we go here and see from that point on that is about 15 frames. We can slow it down. So I'm gonna drag out a time set, then set the time set here to frame change it to 15 with no variations. So after 15 frames, it should send it over to that event. And here we're gonna go and shift drag force and gravity. And we could go and select those and make them instances. So we change one thing, it will change it overall. And then I'm gonna go and add a slow operator right in here. Just press tab and type in slow. And this is what we have. I'm gonna set this maybe to a higher value, something like 9 or so, and then simulate it again. So there we go. Now this saddle is not going forever and bumbling around. So that is what we have. Now we could go and change settings for stretching, maybe in a higher value for the shear as well. So it gives us more wrinkles and stuff. We can set it to constraint, see what the results will be, and give it another go. So you get more wrinkles and stuff, if that is what you want to do. And we could go to force and enable cloth aerodynamics as well. That helps actually more if you have wind effects or noise and stuff like this. But just that we know it is there and we can use it, we do so. I'm going to use that more and more in the other examples I'm going to show you. So now if you're happy with the results and if you're doing just or if you're creating just a table cover like this for a simple or for a steady image, so and you don't need the animations and stuff like that, you could actually just stop the simulation here when you're happy with the results and everything. So I'm going to go to the point you feel like that is okay. And you could, if you have the pro version, you can go and export everything as a tycache and stuff, but that is not available in the free version. So tycache is not given. But for such a case, you don't need actually to export anything. What you can do is go and add an edit mesh on top of tyFLOW and then right click and collapse it to it. So in this way you just have a mesh, there is no animation, no simulation and nothing, and you can start cloning these and make copies of that and turn them around and create your scene just like this. So that is the first example, and in the next example we're going to take a look of something like a sun protection on a frame and things for an exterior scene. Here we are with our second example. As I said, that could be an exterior scene in a garden or somewhere, and I would like to have a piece of cloth or fabric on top of this frame in order to protect the place from the direct sunshine and sun rays and stuff like that. So let me switch to the top view again and go and create another shape here. I'm gonna create a rectangle for this one and set that maybe to 300 by 170 or so. Make sure it is in the center of my frame, and I'm gonna move it up like this. And again, garment maker, density 0.5. And now we can go and start adding our stuff to tyFLOW. So create tyFLOW and make it center again. I'm gonna set my time steps here to 1/16 and go to my editor. Starting with bird object, pick the mesh, and then press tab, type in cloth bind, and then we need force again, and also collision. So force gravity minus 0.3, and collision, I'm gonna set that to 1 again, as we had it before with the table cover. And we go and let it run and see what we have so far. Sorry, I forgot to add the frame to my collision list here. So again, so the collision looks okay, and the fabric itself actually as well, but there is a problem. It is sinking, so it is sliding away from the frame. So in order to avoid this, we have to make it stick to the frame, and there is a small issue, which is the low poly mesh of our frame here. So there are no, or not enough meshes to work with in order to make that thing really stick to this frame. But I don't want to go and subdivide the frame mesh, because that will just increase the time of simulation for no good reason. And what I need is just having something on top of the frame which is helping me to make that piece of fabric stick to it. So for this, I'm gonna just turn off tyFLOW for now, and then solo my frame here and go to the edit poly mode and select those faces and detach them. And I'm gonna detach them as a clone and call them helper plane or something, and then OK. So now I can go and select these guys, make sure that my pivot point is right in the center of it. And now I'm going to solo those, go and change the color maybe, and then give them more faces, those segments. So let's set that just right to 30 or something. Okay, and then I'm going to select these guys, ring them, and set that to 2. So we have some faces to work with. That is good enough right now. So let me go back and turn on tyFLOW, open the editor and bring it in. So now here I'm going to add a surface test and pick my helper plane that I just created. And I want to say that everything which is within a distance of 1 centimeter, so each particle which is within a distance of 1 centimeter close to that helper plane, that should go to the next event. And in this event, they should go and get deactivated. So we're using the particle switch to do so. At the particle switch, make sure it is deactivate bindings, and then add an object bind and pick that guys again and make sure it is locked to surface. So now we can bring back everything else and just turn off our helper planes and turn off these particles, make these guys red so we can see if anything changes. Now let that go again, and there we go. So now they are sticking to those planes that we created and not sliding away anymore from that frame. So we still have the same issue as we had with the table covers, so that thing takes a while to settle down. So we go and fix this with a slow operator again. So as we did before, drag out a time test. Make sure it is set to frame, set that frame to around 15, I guess. We'll do the job here as well. And select force and collision, shift drag them to this event. Select both forces here again, make instances the same with the collision. And now we can go here, press tab and type in slow and add the slow operator and change the value to something like 9 or so. And now let us see what happens. Sorry, I have to make that bigger so you see what is going on. So there we go. Now it settles much faster. The next point is, if we are creating something like that, chances are that we are actually creating exterior scene and not an interior scene. And most exterior scenes or animations, if you have one, there is a breeze or kind of a wind or something moving the fabric. If I go and change the stuff right here, so what we do first is activate cloth aerodynamics. But if I go and do it right here, it will go and slow down that noise effect and everything as well. So I don't want that to happen. I want it to be there after it settles or while it is settling. So I do another time set, the time test, and set this guy to frame as well. Set that value to something around 40, and then here maybe 0. Well, here we could actually go to 15. Can have some variations in there. We need the same collision and force operators here as well. So just select them, shift drag it to the next one, and then select again, make instances, and the same with the collision. So now here, sorry, the force, we have to make that unique. For the force here, I'm gonna use the noise effect and set the strength to 0.3, frequency or 0.02, scale maybe 36 or something. Then we go to phase 0.02 again, and I'm gonna change it from simplex to Perlin so it is not going that crazy. So that means after it settles, it should still go and simulate some kind of a breeze or wind effect on our mesh. So let it go and see what happens. We actually could set this guy to 25 as far as I can see. The time test here. I just change it to 25. It is going to recalculate it again. Here we see how the noise actually kicks in and does its job. So it actually works pretty well. And this is actually it for this example. So that is how we can fix those problems and create a sun protection cover or something here with some breeze and wind effect. In the next one, I'm gonna show you how we can create a curtain that is interacting with an animated object such as a door or something, and we'll see what problems we have there and how we can go through all them and fix them. So stay tuned. So for this example, I already have prepared some stuff. So we have the frame as usual, and here I have again a rectangle with the garment maker on it and with the density of 0.5. And when I disable or hide that, we see these two doors, and the blue one is animated, and within 3 seconds it opens. So now I want that curtain to interact with the door. So we're gonna start with another tyFLOW setup, and let's go and set that directly to 112 for now, and open the editor. So here we do the same thing. It's a bird object, and then we're gonna go and select the fabric mesh, then press tab and type in cloth bind, and we need force as usual. Gonna set that to -0.3 again. Then we need collision, and I'm gonna pick the frame, the fixed door, the animated door, and now I also have my helper plane here on the top, as we did it in the last example, just in order to be able to stitch the curtain to this guy. And this is what I'm gonna do right now. So go and create a surface test, bring it just underneath of the cloth bind, and send the particles to the next event when they are within a range of 1 centimeters to this helper plane. So then we go here, press tab, particle switch, deactivate them, and press tab again, object bind, and bind it to this guy and lock it to the surface. So now when we go and unhide everything, that is what we have. We can go make these guys red. They are up here, so I can go make them bigger maybe. There we go. And that is our first setup for now. So I'm gonna hide the helper plane. We don't need to see this. Then I'm gonna run the simulation and take it from there and see what we have to fix. And we can see we have some collision problems as usual. And the other thing is that this door just rips through the entire curtain. So if we go with the settings as we had before, and then we have some animated stuff, we could have some issues we are running into. So let me stop that and address all these issues. So the first thing is actually our collision. So we go and fix that first. And I'm gonna set the collision radius here to some around 1.5 and set the bounce to 30, so it bounces off the surface just a little bit more. And I'm gonna go and bring down the friction to 0.1 because I don't want any friction between the door and the cloth mesh. actually. It should just slide away from it. And this is good for now. And for the ripping that it goes through the mesh and stuff, we have to set our time step to a higher value. So 1/24th should actually fix that problem as well. Because the door is pretty fast and it goes, yeah, it is 3 seconds, it opens. And this is why it rips just through the curtain when we don't have enough time steps in between them. So just let us see what we got now. Will take a little bit longer when we go for the higher steps and stuff, but it's worth it. It's actually the way to fix that. And again, we are not using CUDA for all the things. This is what we have, what we need. Actually, more steps than usual. So let's see if that will fix our issues that we had before. So the collision looks better now. Actually, it is fixed, so it is not coming through the mesh. And the ripping looks actually good as well. And it slides away from the door, so it is not sticking to the door because we lowered the friction value. And the next thing we're gonna fix, or we will have to fix, is the self-collision of the cloth mesh. So we take a look at this. That's good, it's not bad. So now we can go to force and then activate cloth aerodynamics again and get back to cloth bind and set the stretch to 0.75 and the shear to 0.75 as well. And then let us select constraint and see if we have the look of a lighter piece of fabric. And we should have more wrinkles and stuff in it. It should look better than before. So our simulation's halfway done. Gonna stop it here and go and address the issues we still have to solve. Looks much better. Looks like a much lighter piece of fabric and curtain that reacts pretty cool to the door and everything. But here we have a problem, and this is the self-collision. Usually we use CUDA to solve it, but since I'm not using it in this tutorial, we're gonna use particle physics, so that will help us to fix this issue as well. So we go right here and add particle physics. Bring it above the force. Let me just deactivate it for a second. And for the physics radius, I'm gonna set it to absolute and make that maybe 0.63 or something. Tolerance, we can leave it the way it is. Stiffness, I'm gonna bring it up to 1, and then ignore starting penetrations. That is important that you turn that on. So let's go and take a look at our collision spheres. These are these guys here. We'll make it maybe like this. Okay. So yeah, the size looks okay. These are the spheres that will go and interact with each other and create sort of self collision effect. So let's go and turn that off. Everything else is actually good, looking good so far. Now I'm gonna render this again, actually simulate it again, sorry, to see how that works. So let it go. There we go. So simulation is done now. And as far as I could see, there is no issue with the self collision and nothing. So it looks pretty cool. Now that is where the self collision was doing its thing, and everything looks nice and smooth. Okay, this is done, and in the next example I'm gonna show you something similar with the opening window and some wind effects, so how we can use some wind and simulate the curtain with that as well. So let's go and start our next example. So here in this example, I already have everything set up as we did it just before with our door example. Is everything actually exactly the same? So it is both objects and the cloth bind, which I changed the stretch and the shear values to 0.75 and set the stiffness solver to constraint. After that, we have the surface test, which I'm using the helper plane again, which is this guy. And go and attach everything which is in the range of 1 centimeters to it and deactivate the particles. So in this object bind, I'm using the same plane again and bind the particles to that. So it is preventing them from falling down as we did it in the examples before. So I can go and turn that off. We don't need the wireframe. And after that we have force and the gravity. Here I go and activate the cloud aerodynamics afterwards. I also use the particle physics in order to simulate the self-collision effect. And here we have the collisions, and for the collisions I did something extra, and this is creating some helpers as my collision object, because when I go and just run this, see how the simulation works. And for the collisions, what I did here, I didn't use the panel and the window elements actually by themselves as my collision objects, but what I did was creating some helper geometries actually. So this one acts as my collision object for the panel, that green guy is for my handle, and this blue one here, the dark blue, is for the frame of the window, which has also that hole in it where the panel will get closed and stuff. So when I close it, it looks like this. And when I run the animation, this is what actually collides with the fabric, with the curtain here. And that gives us this effect. And these extra geometries will make the calculation much easier for tyFLOW, and you're not spending a lot of time calculating all the elements with all the shapes and stuff. So that is an easy way to fix collision problems. And the next thing I would like to add to the scene is just a wind effect. So when we open the window, some wind should blow in and interact with the cloth. And this is why I would go to my force, activate the cloth aerodynamics, and add a tyWind into my scene. Just center it, push it back, go to the left view, and bring it up about here. And for its settings, I'm gonna choose a strength of 2 centimeters maybe. And here the planar distance, we can go and change it. We can go and change it to something like 300 or 350 or something. And the fall off, let's set it to 30. That means that the wind effect will actually end after these icons here, and everything behind that will not get affected. So if you have some other curtains here or some clothes and other objects here that shouldn't get affected by the wind, this is the way to solve that. So you can actually just create the range where the wind should go and where it should end. So I would also like to use some noise here. So let's go and set the noise strength to 0.3, frequency maybe 0.02, scale it down to 30, and set the phase to 0.02 as well, and the speed maybe 0.3. So I'm gonna let that go and simulate it. Before I do so, we have to define the collision objects as well. So I'm gonna check on collide with cloth meshes. This is important actually. And I'm gonna pick some stuff that we have in our scene, such as the frame, the wall, and also those collision objects that I created for the frame of the window and the panel. So here I don't need to add the handle because it is behind the panel anyways. And this is it for now. So the next thing is adding that wind to our force inside of our event. So just go to force and pick the wind, so it will go and affect all the elements here. So now the wind will get used, and let's see what the result will be. So this animation is also, simulation is also done. So now go and run this. We have now the wind, which affects the cloth mesh here. And you can see that it affects it only there where the panel is open, and everything behind the wall and etc., or behind those collision objects that we have defined, is getting less affected by the wind as it would be in the real situation as well. So this is how it looks, and I'm actually pretty happy with the results. So in the next and last example, I'm going to show you how you can create some string curtain using tyFLOW and adding some noise effect and etc. to that as well. For this example, I have already prepared some stuff here. Actually not much, but let me get rid of the frame for now. But what I have is just a plane with 32 segments. And why this is important, I'm gonna show you that in a minute. And as usual, my helper plane in order to stitch that to this one, as we did it just before. So now let me just go and set everything up for our string curtain and show you how we can do this from scratch. So here's the tyFLOW again, and let's go and set this to 1/8. I should actually do the job. And in our editor, I'm gonna start with birth object, pick that piece of fabric as our mesh, and then start adding cloth bind into this. And we also need force, and we will need collision. So in my force, I'm gonna set the strength again to -0.3, and everything else I'm gonna leave it for now. But I go down here and activate cloth aerodynamics. So in my collision, all I need is actually the frame here, and we need to stitch that piece of fabric to this helper. So we go back here and press tab and add a surface test. And pick the helper plane here. Right click, switch output side. So I'm gonna drag it down to this side. And here in this event, we go and add particle switch, deactivate them. And we also add object bind again and select the helper plane here. So this should switch those guys to red and stick them to that plane. So for the distance, we have to set it to 1. And we are good to go actually. So let me do that blue or something. So when I run the simulation now, it is actually hanging there and everything is fine. So now in order to create the strings underneath of this piece of fabric, we go to the top view and create a box just as big as the fabric itself. So let me go to the left view, put that aside for a moment. Let's go here and maybe make it 2 centimeters, 175 maybe the length, and the height is 1 centimeters. And I'm gonna push that up and bring it here. Make sure that that particle is inside of it. So -100 is actually where it should be. So let's go here, and now we go and make it see-through and not renderable. Now in my tyFLOW, I'm gonna add another surface test and pick this guy that we just created and say instead of distance in surface test mode, I'm gonna switch to volume inside. So everything which is inside this box will get sent to this next event. And as soon as it is here, we go and spawn it. So spawn operator. And we send these guys now. No, we don't have to actually. Yeah, after spawn, we set this to a color I can see better. Darker blue or so maybe. And make them bigger. So we have them here. And I'm gonna spread them along the z-axis. So the random spread we're gonna set it to 0, and z we go to minus 200 or something. And I'm gonna bring it out in this case. So do it like that. So switch these guys to green, and those guys should be down here now. So after this we need the resample, sorry, just forgot the name of it. And set the threshold to about 6 and resample parent and children. We go make it 1 again. And then we go and add a particle bind. Disable in the proximity bind. And we're gonna use family bind, activate bind to siblings and bind to parents, and show binding, so it shows we're doing. And that looks actually good. So what we need here is force and collision again. So I'm gonna select these guys, shift drag them right into this event. Let me just turn off the particles and run this simulation real quick to see what we've got so far. So that looks good. Everything works the way it should. Now, in order to convert these lines to meshes, we go and add a spline path operator here, create new, and then go and select the splines, tySplines. Go to the tySpline settings, select weld bindings, activate this eye for the viewport, and make sure you select particle bindings, and that will just go and show that as a mesh. And for the mesh radius, I'm gonna set it to 0.2 maybe, or 0.15. That should actually do the job. So this is what we have so far. We go and turn off the particles so we don't have to see them, and also get rid of this box here. So hide it, actually, not getting rid of it. And I'm gonna hide my helper plane as well. So we go and simulate that again. Everything stays in place, and that's cool. So let's go back to our force, select both forces here, right click and go to make instances. And for my force, I'm going to use some noise here. So 0.3 as the strength, frequency 0.02, then scale down to 36 maybe, and phase to 0.02 as well. Then I'm going to change it from simplex to per lean, and maybe 03 is just too high. We'll see, but just let it go and see what we have. Yeah, 3 is just a little bit too high maybe. So let me go and set it to 0.15 or something. Yeah, that looks much better. So now what we can do for the bottom part here is go into this box again, shift drag it down and just make a copy. Go to the left view and come down here, turn on the particles, and let me turn off the tie splines for now and bring this guy to that point. So just make sure that this particle is inside of it again. And we go and drag out another surface test and add this box to it. Switch from distance to volume inside and send it to the next event. So in this event, we're going to use again force and collision. Shift drag it into here, and I'm going to add a shape operator here and go and select it as a 3D object and select sphere. Mid-rest should actually do the job. So put it above everything, and now all the particles on the bottom are changed to a sphere, and that makes it look like there's some weight and something at the end of it, which I think gives it a better look than having nothing down here. So let's go and maybe go for 200. Now turn on the tie splines again, turn off the particles, and now let us go and resimulate it. It looks like we could go and just make the instances here again and change the size and the scale of noise. Gonna put it to 18. Run that again, because that will give us a much better result than those big things. Yeah. Looks better in my opinion. And now the good thing is we can go and change the amount of these strings pretty easily without having to change anything in our tyFLOW as such. So we go to our fabric mesh, and the only thing you have to change is these segments. Just set it to 64, for example, and everything else will go and update itself. Just be careful if you go too close or if you have too many of them, you may have to rescale these weights on the bottom so they do not go and intersect with each other. So let's go and resimulate it. And that looks actually pretty good. This is the way you can create string curtains. The last thing I would add to it is particle physics so that these guys are going to interact with, collide with each other if they are coming too close. So let me go and set the size, the multiplier to 1.2 or something. So just slightly bigger as the sphere, but still not too big so that they are not going and running into each other. So there should be a good amount of space between them. I guess 1.15 would do the job. And now if we go and resimulate that, they should actually collide with each other if they are coming closer than those spheres. Yeah. That works fine. Let's open that and check draw collision spheres, and this is what we get. So when I bring in the frame, everything looks nice, works good together. Okay, this is the last example. I hope this tutorial was useful to you and that you have learned something you can use for your everyday project. Wishing you a great and successful day. Bye-bye.